In this video, we're going to talk about balancing nuclear reactions. This is a type of problem that you are going to get on the MCAT. It's something that you'll need to know how to do in terms of describing the different types of decay. So by the end of this video, we should be able to balance the nuclear reactions for our 4 types of nuclear particles that we learned about in the previous video. So just to remind us, we've had alpha, we've had beta, we have gamma, and positron. And alpha looks like this, beta is like this, gamma, and positron is the opposite of an electron. So we've had these 4, which you've described in detail previously. There are 2 rules to balancing. The first rule is that mass is conserved. And the second rule is that charge is conserved. So mass is the number that we have on top. Just remembering our isotopic notation, the top number is our mass number, and the second is charge, which is the bottom number, or our proton number. These 2 are always conserved in actually any reaction, but we're going to focus on these 2 in particular when we do problems. So there are actually 3 steps we can follow to balance reactions. So the first step is we write the emission particle. This will make more sense once we do a problem on it. The second step is we subtract our reactant minus the emission particle. The last step is we write the new atom. And this is super important. In chemical reactions, we've said that the protons don't change and it's the electrons that are being transferred or shared. But in nuclear reactions, what's different is that the proton number can actually change. So we can actually make a brand new atom. So, lead to gold is actually possible in nuclear reactions. So let's give one a shot. Let's say we have uranium-238, and let's say undergoes an alpha decay. So first step is we write our emission particle first, and then we subtract. And what we mean by that is we need to make sure that mass is conserved. So we say 238 minus 4, because you can think about it like you originally had a mass of 238 and you're forming 2 things. So the other thing has to be the remaining mass. So 238 minus 4 gives us 234, and 92 minus 2, because our charge also has to be conserved, gives us a 90. So the new particle that we've made is 234, 90. We need to go to our periodic table to find 90, which is our new proton number, and that gives us thorium. So thorium. Another problem that we can see is, let's say we had our thorium and we underwent another decay, but this time we are doing alpha decay. So first step, we write our emission particle first, and then the second step is we have to subtract to balance. So we have 234 minus 0 is 234, 90, and this is where students mess up a lot. I see this all the time in student work. 90 minus a negative 1. You need to make sure that you're accounting for the negative in your product. So this is actually a 91. So what we formed was 234, 91, and we have a new atom. It's not thorium anymore. So we go back down, and 91 is Pa. So we go back up here, and we can write the new atom. Let's try one more. Let's say we had another step to this problem. Let's say it said, well, it undergoes another gamma decay. So we had 234, 91, Pa, and undergoes gamma decay. Gamma is actually the easiest one 234 minus 0 is 234. 91 minus 0 is 91. So we form the exact same thing. So 234, 91 PA. And lastly, we had our beta decay. I'm sorry, our positron decay. So let's say we had our one more decay, and we said we are undergoing a positron emission. So we do the same step. We have 234 minus 0 gives us 234. 91 minus 1 gives us 90. So we end up with 234, 90. And funny enough, we're actually back at thorium. Okay, so these are our 4 different types of decay. Let's try a challenge problem that is similar to a problem that might appear on the MCAT. So it says we have 216 polonium, and it undergoes 1 alpha decay and 1 beta decay. So what will this produce? So our work, we have to say 216 PO, and we have to actually find polonium. So we say, we look into our periodic table, and we're looking for PO. So we have 84. So our proton number is 84. Our charge is 84. We're doing 1 alpha decay, so 4 to helium. And then we subtract. So we have 216 minus 4 gives us 212. And 84 minus 2 gives us 82. So we have 212, 82. And we look into our table for 82. So we have Pb, which is lead. And then we have one more decay. So we're done with alpha. Do one more. So we have beta decay. So we have 212, 82, Pb, and we're undergoing 1 beta decay. We do the same thing. 212 minus 0 gives us 212. 82 minus a negative 1, again, that's the tricky part, will give us 83. So we have 212 over 83. And we look down, and 83 will give us bismuth, so Bi. And we write down Bi. So this is what we produce after 1 alpha decay and 1 beta decay. So again, in summary, make sure you're balancing your charges, which are your bottom numbers, and your mass, which are your top numbers. The easiest way to do this is just subtract, like we've been doing. And be sure to try a few problems to make sure you can get these points on the MCAT.